In this video, we're going to look at Hess's Law Lab and just look at a few key points for that. Sorry, I'm looking for something here. Let's see if we can find it. Okay, here we go. So this is just some sample data. Check over your stuff. Make sure you understand kind of some key concepts. And I just want to point out a few things that you should be knowing. Now, it looks like I used a thousandth of a gram balance instead of a hundredth of a gram balance. So that's why I have more figures here. I go through, I calculate. I think there was not too many issues with that. Make sure you're showing your work. Oh, a little bit of a typo. I think I had 101.58 grams, but I think the calculation was right, or it's going to be very close anyway. And this is what I come up with. Now, a key thing, a couple key points is this was an exothermic reaction, so you should be saying negative. Okay, you were limited by the temperature, might have been the moles too, but the temperature was 3 sig figs, so you should have 3 sig figs here in your answer. So you got to have this negative sign if it's exothermic when I say delta H. Okay, it's just like, what was it? This is like saying, how much money did you lose? And if you said $155, you don't really have to say a negative value. But if I said, what is the change in your balance in your account? And you just say 155, that might be assumed to be a gain instead of a loss. So the negative sign is important to have in that there. Okay, the other thing is units. If you say kilojoules, you will not get credit here. You have to say kilojoules and standardize it per mole. Technically, they like kilojoules per mole reaction. I don't think they'll call you on that for not doing reaction, but I would get in the habit of writing that. What does it mean when I say kilojoules per mole reaction? It really is just meaning that for every 1 mole of this combines with 2 moles of this, it forms 1 mole of this, 1 mole of this, and it releases 155 kilocalories. So that's what that means. So be careful. Look for the sign and make sure you're using the right units here. Don't just say kilojoules. You will not get credit for that from the AP folks. We're very unlikely that you will. Okay, again, convert grams to moles, different things, make sure, let's see. And notice I did do this right here. Again, whether I use 100 or this, you technically should use the grams of the other piece, but it's mostly the mass of the solution that's having the big, or the liquid, the hydrochloric acid, having the biggest mass in this solution. Okay, again, energy released, and then I have a negative value here, and I do say kilojoules per mole reaction. Okay, so those are just things to be careful of. Just a little bit here, this equation got flipped, these two didn't, and we added up to equal our reaction. Notice if I write it in terms of equations, I write plus for the endothermic here, and I write plus on the right side for the exothermic thing. So overall it was exothermic. I had this amount right here. I could also write delta H's, and then I do the plus or the minus when it was exothermic and match that up. So I added all these up, and then I do want to have the right sign, and I do want to include units here. So make sure to use the proper units when you do that. All right, maybe just a little bit with, I don't know if I go there, I'm going to look at this reaction. When you're doing your percent error, okay, and I don't have it right here, or no, I'm sorry, in your conclusion, I guess let's go to this right here. We'll just go here. And how did each of the following realities affect the absolute value of delta H? Okay. I was just going to go back one thing and say, I think most people were under the accepted value of negative 602. Now, when I say under, I'm saying under the absolute value of negative 602. So you might add an absolute value less than 602, like negative 570 or negative 580s or something is what I've been seeing. Okay, I think the main reaction, the one that gave off the most, was this one here. And what happens is room temperature had an effect on this, and it didn't raise the temperature as much, and made this smaller, or the magnitude of this smaller. It also made the magnitude of this smaller, but this has a bigger impact or a bigger percentage of things. So therefore, the overall thing went down. And then this was taken actually a theoretical value right here. Okay, let's look at this lab question right here. And it says, how does each of the following affect the absolute value of it? So, be careful. I would talk, instead of terms of delta H, I would talk in terms of the absolute value of delta H. So just to be clear, you could just put the absolute value signs around that. I didn't take off for that, but be careful. You could get called on that. Okay, energy is lost to the surrounding environment. Well, if energy is lost, the temperature isn't going to rise as much during my experimental one. So my experimental is going to be less than my actual. And I think that probably was the big thing that happened in your lab that you did. Okay, be careful with 2 and 3. So we used a heat capacity of 4.18, which is a heat capacity of water. Yet let's say the heat capacity was only like 4.00. Okay, the heat capacity I used, I overestimated it in my experiment. I used the 4.18 when it was actually 4.00. So this would be an overestimation. I used too big a value for the heat capacity, which would make my, since it's the numerator, it would make my delta H too big. So that would be an overestimation. And this one right here is, let's say I used a mass or the density of 100, okay? Well, let's say or I'm sorry, 1 gram per milliliter, but let's say the density was 1.02 grams per milliliter. So I used a value in my experiment of 1.00 when I should have used 1.02. So I used too low of a value, which would make my mass of experimental too low. And if the mass experimental too low, it's going to make this too low as well. The percentage too low is probably not very big. The percentage too high here is probably not too big, but that is the direction of error. So make sure that that makes sense to you. All right, I think those are the main things that I wanted to get about this lab. Overall, good job with it, but there's some things that come up with a calorimetry a lot and wanted to clarify that for you. Thank you.